Am I audible?
Yes, sir.
Okay, thank you for confirming. Okay, just 9 number of participants, including me, are there in the meeting. Okay, anyway, let's start. Okay, just I'm sharing my screen. Uh, yes, guys. Can you able to see my screen?
Yes, sir. Yes, sir.
Yeah, fine. Okay. Yeah, okay, fine. Thank you. In the last class, we have seen how to analyze a simply supported beam by using gravity loads. Okay. Yeah. We have seen simply supported beam analysis. Okay, not yet designed, but we have seen how to analyze and how to check the deflection of a simply supported beam and how to compare it with manual calculations. We have seen all the calculations last time. Okay, just as of now, some new people are there in the group. Just I'm going with the concept. Okay. Uh, Generally, where we see simply supported beams in a PEB structure. Okay. Generally, we use frames, and wherever there is possibility, we have to use fixed beam itself. Okay. If there is no possibility, nothing but if a beam connecting to a web or something else, if there is no possibility, then we have to go for a simply supported beam in a PEB structure. So for that, where can we use the simply supported beam in a PEB structure? That one I'll show you one drawing. Okay. Just I'm showing you one of the proposal drawings. Okay, which I did my project. Uh, just this is a plan of a PEB structure. Okay. This is a 42.8 meter width building and 42.82 meter length building dimensions. Okay. In this, there is a mezzanine with L shape. There is mezzanine, L-shaped mezzanine. So, for example, if we take any frame along grid line, this line, okay, so cross section will be like this. Okay, so in this cross section, you observe generally this is the reserve frame, right? So in this reserve frame, this is the horizontal member you are seeing. This is called mezzanine beam, and this is the mezzanine column. Mezzanine is nothing but a floor. Okay, mezzanine is nothing but a floor. So in technical word, we can call it as mezzanine. Okay, so this is the horizontal member you are seeing. This is a mezzanine beam, and this is a mezzanine column. So this one will be fixed. Generally, wherever there is possibility, we have to fix beam. Okay, so that the sway can be controlled. So there is possibility because this beam will be connected to the flange of the main frame. Okay, so we can fix here, but these members, if you see cross section ice, okay, these members are called joist. These joists will pass in between the mezzanine beams like this. Okay, if you see in the plan, these are green color lines you are seeing, those are called joists. If you see cross section, it will be like this. Okay, these horizontal these longitudinal members will run in between two mezzanine beams so that they will be connected to the web of the mezzanine beam. Okay, so we cannot fix any beam to the web of I section, right? Why? Generally, the concept is that the web takes only shear. Okay, the moment will be distributed to flanges, top and bottom flanges. That's why we cannot give moment connection. Fixed connection is nothing but moment connection. We cannot give fixed connection to a web because web takes only shear. Okay, it cannot take fixed connection. Moment carrying capacity of the web will be negligible. Okay, so we have to give simple connection, nothing but shear connection here. So in that case, we have to use simply supported beam. This is the one case. And if you see the other case, I'm showing you a plan here again. Okay. So if you observe grid line 7, okay, if you observe grid line 7, I told you this is the width. The horizontal is the width in this plan. Okay. So if you see grid line 7, there is one frame. Okay, if you see column here, so but if you observe on the other side, there is no column. Okay, why? Because they are giving some door here. Okay, so there is one frame here but no column on the other side. So in that case, what we do, we have to provide a jack beam. Okay, we have to provide a jack beam in between the other two frames. Okay, so that the frame or the rafter, I can say this is the rafter. Okay, the sloped member, it will be rested on I section, that we can call it as jack beam. Okay, so jack beam will run in between these two columns. Okay, so if you observe, this jack beam should be connected to this web. Here also this jack beam should be connected to this web. So what connection we have to give? We have to give shear connection only, that is simply supported connection. So in this case also we use simply supported beams, like mezzanine joists, jack beams, etc. We use simply supported beams. In the remaining cases, generally we prefer fixed connections, fixed beams. Okay, as we are in basics of the stat, we are analyzing a simply supported beam here with a 5-meter span. Okay, last time how to analyze a simply supported beam we have seen. Okay, so how we have analyzed this structure? We have given geometry, nothing but x direction only. We have taken beam is along x direction only. So we have given some certain nodes, and we have connected these nodes with add beam. Add beam option is there, add beam feature. We have connected these nodes with add beam option, and there we have formed one beam. Okay, simply supported beam is nothing but one side it should be pinned, one side it should be roller. Okay, if you give pinned here also, there is no problem, but if we talk technically, we have to give roller only. Roller is nothing but only y-directional support. There is no x-directional support. Okay, no x, no z-directional support, and there will be no moment. Okay, nothing but translation is allowed. Okay, only y direction there will be support in case of roller. Okay. We can give pin also here because we are giving only dead end live loads. Those are called gravity loads. We are giving gravity loads. We are not giving any lateral loads. Otherwise, we are not giving any temperature. Lateral load, I can say, in this beam, we are not giving any temperature load. Okay, so we are giving gravity loads only. So you can make it as pinned also. There will be no effect in the beam. Okay, so and after forming geometry, we have given properties. So we have defined a tapered section in this like this. We have given 400 web, 400 by 5 web, and 150 by 6 flanges, top and bottom flanges we have given. After that, we have assigned steel this to the steel material property to this section, and we have not given any specifications. In the last class, I told you there are some specifications like offset commands, releases, etc. We have not given anything because it is just like a simply supported beam. We have not given any specifications, and we have defined two supports. One is pinned, another is roller. In this section, we have defined like create. create one is pinned, and how to create a roller support. Fixed butt option is there in the start. Fixed butt, what are the releases we have to give? We have to provide only FY support, only FY support. So what are the releases? Except FY, remaining all the items should be released. Nothing but lateral X direction, lateral force along Z direction, movement along all the directions. Okay. So FZ, FX, FZ, MX, MY, MZ has to be released. Only FY should be there. It should not release. Okay. If you release FI also, that will be free end. Okay. So we are giving roller support only. So we have to give FY only. So that's why only FY support it has formed here. And we are giving loads as dead load and live load. Okay. Dead load includes self weight of the beam. Okay. Self weight of the beam. Here it is in the, sorry, after defining dead load, if you click new, if you click add, there will be one dialog box open. After that self weight command, here you have to give y, you have to give x, y, z. There are certain directions here, you can understand. So how the self weight will act? Okay, gravitational y direction, right? So direction y and factor -1, y -1. Nothing but in the stat, y will be positive upwards. Okay, so I am giving -1 so that gravitational force will act downward. So I have added self weight. Okay, and the next thing I have I have added UDL of 2 kilonewton per meter. Okay, like in the add session itself, member loading is there. Member loading command is there. Uniform force, nothing but UDL. Okay. So it also should be denoted with negative symbol because it should act downward only. Okay. So GY and local. Okay. What is this local? Local is nothing but it is with respect to the member. Okay. Local X direction. It is with respect to the member. If you take I section, if you the cross section, if you take the horizontal, the flange direction will be X direction, the web direction will be Y direction, and the length direction will be Z direction. That is local. Okay. But always we have to follow gravitational loads in global Y direction. Okay. You have to select global Y direction. Whatever value you have to give UDL, -2 or -3 something. Okay. Like that you have to give minus because you have to the gravitational loads always act downwards, right? So we have to provide minus symbol. So minus value you have to give, and then I have done add so that the load will be assigned to this beam, and like that I have upload dead load and live load also here. Okay, so in the analysis command we have done perform analysis. Here define command section is there. No print is means no detailed output will be printed. Okay, nothing but the section pass or fail, it will just show. Otherwise there are certain options like load data, static check, mode shapes. This will be for seismic. Okay, both means static loads and mode shape, all means this will all. Okay, so like that I don't want any output detail something, because I can check by unity ratios whether it will pass or not. Okay, so I am not adding any detailed output here. So I have used a no print command. Like that I have performed analysis and I have done run. Okay, what is the command I have used to run analysis? Control plus F5. By holding control, you have to press F5, function key. F5 nothing but function key number 5. That will be in your keyboard. Okay, functional keys generally they will be on the top of keyboard. Okay, top row, first row, nothing but I can say first row. Okay, in that F5 will be there. By holding control, you have to press F5 so that analysis will be run, and then you can see there are no errors, no warnings, no notes. Okay, so I have done analysis. Nothing but I have given some section properties. I have done analysis. What is the deflection criteria, how the shear force and bending moment diagram will be. So like that, some reports will be generated. Okay. In the post processing mode, if you see here, there are some certain workflow, right? Here, post processing command is there. So that if you go to post processing mode, if you click OK here, there are some set time. Okay. Fx is nothing but lateral force, nothing but lateral reaction. How the lateral force shear force diagram will be, and Fy nothing but vertical shear force, how it will be. Since we have given UDL, the shear force diagram will be like this, right? If you are observing blue color line, okay, so like that shear force, there will be no Fz, okay, because we are not applying any forces in z direction. And if you see mx, there will be no mx, there will be no my, there will be only mz, because we are applying gravity loads only, that to udl. So it will be like parabolic structure like this. Okay, parabolic bending moment will be like in the shape of parabolic, right? So we have done analysis like this, and we have seen the displacement. Okay, so if you double click, there are some certain cursors, like I told you. There is beam cursor, there is node cursor, there is plate cursor, etc. There so many cursors are there. Generally, we use beam cursor and node cursor, because we are not supposed to use any plate cursors here. We are not going to use any plates in our analysis. Okay, just there is beam and there are nodes. Okay, so I have to use either node cursor to select the nodes, or I have to use beam cursor to select the beams. Okay, if you double click the beam, there will be some sections here. Okay, geometry, what is the length, how much is the first, where is the first node, where is the second node, like that geometry. And properties are nothing but what is the cross sectional area, what is the elastic modulus, what is the density of the material, Poisson's ratio, etc. All these things, ixx, iy, moment of inertia, second moment of inertia, about x and y axis, etc. And what are the load cases we have applied, dead load and live load here, and what are the shear force and the bending moment diagrams generated here. Okay, so and we have seen deflection also here due to live load deflection. If you see, that is 1.181. How this deflection will be checked, right? We have seen what is the deflection formula for simply supported beam for carrying UDL over entire length. There will be 5 WL power 4 by 384 here, right? So we have checked in the last section manually. So now we are going to design the same beam. Okay, now I'm taking the same beam, I'm going to design. Okay, there are two methods, like I told you. One is by using user interface, like that you are giving every command in this section only, where you are seeing user interface, this one. Okay, the screen, you have to give every command in the screen itself. Okay, and there is other method called stat editor. You have to, okay, there is the symbol top, right? This is the if you are seeing here, my cursor is there. So paper and pencil command feature is there, no? That indicates stat editor. So generally it will be like a program writing. Okay, so it will be like a program writing. We can also do like this. So as of now we are seeing interface, and in the next class we'll see how to analysis and design a simply supported beam by using stat editor. In the next class we'll see. In this class we are seeing user interface method. Okay, so if you go with, we have done up to analysis, right? We have done up to analysis, but in the loading, any structure in the civil engineering, any structure should be designed to carry design loads. What are the design loads? Design loads, nothing but technically we can say they are combinations. Generally, we will not design any structure for a single load, either one single dead load, either one single live load, either one temperature load, either wind load. We cannot design. We will not design any structure for only independent load. Okay, so suppose I am designing this structure to carry dead load and live load. Okay, so it should pass the dead load and live load combinations also, right? So for that, we have to apply some combinations according to the code. Okay. In this class, we'll see how to apply load combinations in any code. Suppose let us take in this class, we will see American code, AISC. Okay. In the next class, otherwise tomorrow. Okay. Tomorrow we can see IS 800. Okay. By using star editor, we can see IS 800. Like that, I will tell you, so that both methods will be covered and both codes will be covered, American and Indian standard. Okay. So like that, suppose, so how to create load combinations? Okay. If you go to the loading, okay, here you can see analytical modeling. There are features, geometry, properties, material, specification, supports, loading, analysis, and design. Okay. If you go to the loading feature here, one dialog box will pop up here. Otherwise, if you can create by using automatic load combinations here. Okay. So either way you can create. If you click plus symbol here, it will open up what are the loads you have given. One is defined as dead load, one is defined as live load. Okay. If you click new, here you can see load cases. Okay. If you click combination here, here you have to mention what is the combination case you are using, and you have to use partial safety factors. Okay. Here, if you click this one, it will move to here. What is the factor you are going to use? Okay. Generally, safety factors. We are okay. Safety factors will be used for combinations. Suppose if you go for let us take what I can say, ASB. Okay. Allowable stress method. If you go for allowable stress method, what is the dead load and live load partial safety factors? Those will be one. So one partial safety factor for dead load and one partial safety factor for live load. Like that we'll see. Okay. And there is another option, auto load combination here. You can observe auto load combination option is also there. If you don't feel everything difficult, because everything will be defined itself here. If you see auto load combination here, you have to give the code here and what is the table number or category you have to choose here. If you click generate, the load combinations will be generated. So here also you can create. Otherwise, if you click automatic load combinations, okay, if you click automatic load combinations, it is asking you automatic load combinations or edit automatic combination rules. If you have predefined any combinations, you can edit them also. Because I have created only two independent loads. Generally, we call it as primary loads. Okay, dead load and live load, independent loads. We can call it as primary. We can call them as primary loads. Okay, so I have not defined any combinations here. That's why I have to define combinations first. Okay, so I'm going to define combinations. For that, one dialog box has opened here. So select load combination code. Okay, if you see here, suppose I'm using AISC, right? First in this session, and tomorrow we'll see IS 800, because there are two methods, user interface method and stat data method. In the stat data method, we will see IS 800. Okay. So in this section, we are using AISC 360 2010. Suppose, let us take, this is an example, right? You can try by your own with any code. Okay. I'm using AISC 360 2010. What is the category of building? General structure or public structure or garage structure? Public structures means parks, shopping malls, etc. General structures means simple warehouses, etc. Garages means any workshops, like that. Okay. So what is the purpose of the structure? You have to select general here. Okay. So what is the starting load combination number you want? Okay. I prefer, because I have defined load cases 1 and 2 right here. Dead load as load case 1, live load as load case 2. So that's why it is starting from 3 by default. Okay. I can here give 100 also. Okay. If you click generate loads, it has defined like this. Okay. It has given loads like this. So don't confuse what are these numbers. I'll tell you how to identify. Okay. So I'm just closing so that you can understand. I'm not adding these combinations. I'm just closing. Okay. So what is the load case 1 here? Dead load. What is the load case 2 here? Live load. I am now applying automatic load combinations. Just I'm repeating the part. Okay. To understand you. ASC 36010 I have selected. General building I have selected. Okay. So starting case, suppose let us take 100. Generate loads. It has generated partial safety factors, or simply I can say load combination factors it has generated. Okay. So you can observe 100. 100 is nothing but this is the load case number. 100, 101, 102, 103. These are load case numbers. One, one is uh, one is nothing but the primary load case number. 100 is 100, 101, 102, 103. These are combination load case numbers. One, you can observe one here, two here. Okay. One is nothing but primary load case number. Primary load case number one is what is the primary load case number one? That is dead load, right? So here only it has applied one partial safety factor for dead load, and in the second case, in the second load combination, it has applied one for dead load, one for live load. Okay, one for dead load, one for live load. And in the third load combination, it has applied one for dead load, 0.75 for live load. In the third case, it has applied only 0.6 for dead load. So how these load combinations has been generated? So I'm going to AISC 36010. These load combinations is defined in ASC 710. If you go through ASC 710, okay. Okay. So you can see here, these are basic combinations. Okay. You can observe here, basic load combinations here mentioned for allowable stress design, because I'm doing allowable stress design for suppose. Okay. It has given one, there is nothing in before D, nothing but what is the multiplication factor here? One into D is nothing but D. So what is the partial safety factor here? One. Okay. So one dead load is the first case. So what is the stat generated? So one partial safety for dead load, right? So first case is satisfied. And the second one dead load plus one live load. Okay. So one dead load for load case one factor for load case one factor for load case two, nothing but one for dead load, one for live load, like this. Okay. Either way, you can use the L is nothing but floor live load, LR is nothing but roof live load. Okay, we have given only one live load there, so it has taken either way it is the same, right? One is dead load, one is live load, one is dead load, one is live load here. So either way it can take. And the third one, this case, right? So dead load partial safety factor is 1, and it for live load it is 0.5. If you observe third one, for dead load it is 1, for live load it is 0.75, and the last one load here where, right? Okay, the last one remained is 0.6 dead load, so 0.6. So what is the critical load combinations? Because I'm just designing one beam only here. What is the critical load combination here. So it is 1 and 1, because if you take first case, it is factorizing only 1. There is no zero factor for live load, so it is not considering live load in the first combination. So this is not the critical one. Okay. Sorry. Okay. If you take the second case, it is factorizing 1 for dead load, 1 for live load. That is the second case. Keep it aside. And the third case, if you see, 1 for dead load, 0.75 for live load. So in this both, which is the critical one? 1 for dead, 1 for live. This is the critical one, right? So remaining all these are will be lesser than this one, right? Because both are 1 here, second combination. Remaining all will be lesser, right? 1 and 0.75. This is only 0.6. This is only 0.5. 1. So we have to consider this 101 case only in our design. Okay, so that is the only, if you see, discarded load combinations, selected load combinations here. So we have to use 101 only here. So remaining all these will be sent to here. Only 101 will be sent to selected load combinations. If you click add, do you want to sorry, before I have analyzed it, right? So it is asking whether you have to delete all the result files. Yes, I can run again analysis, right? No problem at all. I have added load combination here. So close. Okay, if you see here, ULC, nothing but ultimate load combination, it has created 1 dead load, 1 live load. So 1 is for dead load factor, 1 is for live load factor. Okay, so that's why it has factorized.
மணி 8 மணிக்கு சாச்சிருவாங்கம்மா, சீக்கிரம் வாரேணும்.
Okay, someone disturbing. Okay, fine. Okay, now we have given load cases, load combinations. Okay, so as I told you, we should not design any structure for independent load case or primary load case. We have to design a structure for load combination cases only. So for that, we have given 3 loads here actually: dead load, live load, and load combination. So these 3 are different loads. So STAT does not know directly which combination it should be used for design. So we have to tell it. Okay, so which load case you have to, STAT has to use that, we have to give the command. So how to give that command? If you go to analysis and design section, there is one option here, load list. So load list is nothing but whatever the load combination or whatever the load cases you have mentioned in the load list, that only will be considered in the design. Remaining all the combinations or load cases will be discarded. Okay, so that's why this is the most important command in our design. Okay, load list, if you click load list here, it is asking which one you have to, which load case you have to use in the design. So we have to design it for load combination case only. We should not design for independent cases. So I have to select combination case only, and that should be sent to selected type. Okay, this is the selected, and these are available. Okay, I have selected this one only, so I have sent to this side. So if I click OK, load list will be added here. So after that, we have to go for design directly. Okay, so because we have analyzed, we have applied loads, we have analyzed, nothing but perform analysis command has given. So nothing but the last part remain is design here. If you click design, this dialog box will appear here. So you have to select the code. This is the most important part, because whatever the code you have to select here, those parameters only will show here. Okay, so suppose I'm using ASC 36010 load combinations, right? So AISC 36010 here, I have to choose. Fine. So there are some set time parameters. Just why it is showing some time remaining meeting time, it is 1.26 minutes. Okay, probably they have some certain license issue. Probably organizer have some certain license issue. That's why after this 1 minute, this meeting may be ended. Okay, please do not feel anything. We will share you the link in the group again, new link, so that you all can be connected. Okay, probably this will end in less than 1 minute. So probably I have to stop here because it will end. If you, meanwhile, if you have any doubts, you can ask me. We'll share you the new link after this meeting has been ended. Okay, we'll share you the new link so that you can connect once again, just within a minute. Okay. Fine. Okay, I'll ask organizer about this issue. No problem. We'll. Okay, fine. Let's start again. Just I'm sharing my screen again. Sorry guys, sorry for the issue. Okay, I'll continue the class. Where are we? Okay, in the design. Okay, so am I audible, right? And my screen is sharing to you, right? Okay, fine. Just in the design section, if you see, you have to careful with the code selection. Okay, because if you while creating a structure itself, the default will be concrete in the some of the style. So if you does not click like the if you does not select the proper code here, it will not show the appropriate parameters. So you have to careful while selecting the code here. Okay, AISC 36010, and here there are three buttons are there, nothing but select parameters button, define parameters button, commands button. Okay, first of all, if you click directly define parameters, there are some certain unnecessary commands. Okay, this is simple beam analysis. Okay, don't confuse with the parameters. I'll explain every parameter I'm using here. Okay, what are the parameters necessary for a beam? What are the parameters necessary for a structure? I'll tell you everything. I'll explain them while using them. Okay, so first of all, click select parameters. Okay, so here you can see like available selected. There are two columns here. All these are unnecessary because I'll shifted everything to the left. Whatever I need, I have to shift them to the right side. So first one, beam parameter. I'll tell you what is the beam parameter and what is everything. Whatever, just look at these parameters. I'll explain in the detail. Okay, just beam parameter I need, and FY yield stress of the steel, and ultimate no need because it will be calculated directly by using yield, and KZ or LZ you can say directly LZ, and LY. Okay, method, and STP, and track UNT, UNB. Okay, these are the selected parameters, design parameters. Here I have selected. I'll explain you each and everything in detail. So I have added just. Okay, so after adding this, if you click define parameters, whatever the parameters you have added, those only will appear in the design parameters section. Okay, first the command is beam. Okay, what is meant by a beam command? So beam command or beam parameter is nothing but if you want to design entire beam as a one section, you can select 0. Okay, otherwise if you select 1, it will perform design at 1/12 of the every section. Suppose if you let us take an example of, suppose if your beam length is 12 meters, let us say, for understanding I'm telling you, suppose if your beam length is 12 meters, it will perform design for every 1 meter. Okay, every 1 meter segment it will design. In these 12 segments, if any of the segment fails, it will show the entire beam has failed, like that. So the very useful command is beam 1. Okay, so I'm using the beam 1. Understood beam 1? So it will perform design at every 12th section. Okay, 1/12th section. Okay, if your beam is 12 meters, so it will perform design for every 1 meter. If it at any 1 meter it has failed, it will show the entire beam has failed, because safety is our first priority, right? So it should not fail anywhere. Just a minute, give me a minute. Okay, so okay, next one, FYLD. I have added beam command here, and the next one, FYLD, yield stress of the steel. Generally, I have told you 340 or 345 MPa steel we'll use. Just in the second class, I think so. I have told you the same thing. I am doing here 3,45,000. Just adding that. After that, LY. So okay, before going to the LY, just I'll tell you some things. Okay, I have closed this. Okay, if I double click on this beam, it will show some features here: geometry, property, and loading. So if you click property, this is the cross section. Okay, we are using welded plate section, right? We are not using any hot rolled. I told you what is the difference between hot rolled and welded plate. In this example, we are doing with welded section. You can do it with hot rolled section also. In this example, I am doing with welded section. Welded section is nothing but flange plates and web plates will be taken independently and they will be joined with welding together. Okay, so that is the welded plate section here. Okay, these two are the flanges and this is the web. So thus it formed I section. So if you closely look at I section, this horizontal direction along the cross section. Okay, this is the cross section, I shape. This is the cross section. So this horizontal direction is X and vertical direction is Y, and along the length beside here, length is 5 meters, it has written, right? So this is the length. This is the direction is Z. Okay, so local X, local Y, local Z. Understood clearly? So if you have to go for cross section only for this case. Okay, so in the cross section, the horizontal direction is X. Okay, the vertical is Y, and the longitudinal along the lengthwise it will be Z. So okay, for example, in this drawing only I'm telling you, where is that? Okay, so if you take mezzanine beam, this is not a simply supported beam. Just for your understanding, I'm telling you how we use LZ, LY, UNT, UNB parameters, how we will use. I'm just explaining you by taking this as an example. Okay, this is the beam. Okay, if you see here, you are seeing web here, top flange, bottom flange. Over that mezzanine slab is there. Remove that part as of now. Okay, so this is the web. Okay, remove these I sections. These are joists. Okay, we are talking about mezzanine beam. Nothing but here 7.58 portion is there. No, this length. Okay, so that is the beam we are talking about. Okay, this is the web. I'm zooming in. This is the web. This is the top flange. This is the bottom flange. Okay, so how the LZ, LY, UNT will be, we'll see. Okay, LZ is nothing but effective length of a member. Effective length of the member in length direction. Just someone again unmuted. Okay, effective length of the member in Z direction, simply. Okay, simply effective length of the member in Z direction. So what is the effective length? Effective length is nothing but normal length into effective length factor. Okay, normal length into nominal length into effective length factor. So effective length factors, generally there are no predefined effective length factor for beams in any code. So they have given it for compression members only, because they have given it based on buckling axis. Okay, so that's why they have given only for compression members, nothing but columns for the columns they have given. So there are no predefined effective length factors for beams. So we can take it as 1. There are nothing but it will be 1. Nothing is nothing but factor will be 1. Okay, so like that. So kz will be 1 into length. So what is the length of the beam? In our case, I'm going to our case now. What is the length of the beam here? 5 meters. So I have to define LZ as, first of all, I'm taking LZ here. So I have to define LZ as 5 meters. Clear? LZ 5 meters I'm adding, because that is the complete length of the member or effective length of the member. Here in the technical words, length in local z-axis for slenderness KL by R. Local z-axis, I told you, z-axis is nothing but along the length direction. Local z will be right closed. Okay, and then we will see Ly. So Ly is nothing but, if you go to property, this is the y direction for I section, right? Ly is nothing but, if you see what is the vertical direction here, so it is generally web, right? So what is the unsupported length of the web? That one we have to take. Okay, Ly is nothing but unsupported length of the web generally. Okay, please be clear cut in this concept. So okay, generally they will say, technically they will say local buckling axis along local y-axis, sorry, buckling length along local y-axis, they'll say. Local y-axis is, what is the member along local y-axis? That is the web, right? So web. So what is the unsupported length? Unsupported is nothing but there is no braced, nothing but, if you see here, I'm going to the drawing to make you understand. Okay, I'm taking this beam as example, right? So generally joist will provide web support to this beam. This cross section, I sections you are saying, right? These are joists. Okay, this will provide lateral support to the web, right? Because we are connecting this to the web. So they will provide some lateral support to the mezzanine beam. So the joist spacing can be taken as Ly in this case, but we are designing simply supported beam. Okay, simply supported beam for example, let us say we are designing a joist. So joist will be in length direction along the z direction. So the joists will be like this, right? So how the lateral support will come to the joists? So there will be deck panel over here. Okay, so what is meant by deck panel? Deck panel is, it is a sheet to support concrete in the flooring. Okay, while doing flooring, there will be some sheet lead on this floor. Okay, it will be like corrugated. How it will be? Okay, sorry. Like this. Okay, these type of sheets have you seen anywhere? Generally for roofs, for walls, and for mezzanines, we'll use these type of sheets. Generally we can call it as corrugated sheets. Okay, so this is the type of the panel we use generally for mezzanine slab. Okay, so this panel will be connected to the joists. Okay, so by using screws here. Okay, so how the screws? So here like this screws will be laid. Okay, so in the joist, these screws will provide lateral support to the joists. So we can take the screw spacing can be as Ly. Clear all of you? Because these sheet will be laid over joists. Okay, so these screws will be connected to the joists by using deck panel will be connected to the joists by using these screws, right? So these screws will provide lateral movement of the joist. Will avoid lateral movement of the joist. So nothing but they will provide lateral support, right, along the minor axis Ly, I can say. So suppose let us take generally, okay, generally I'm telling you, this dimension will between these two screws will be around 300 mm, or I can say 1 feet. Okay. So I can take it as 1 feet. So in our case, it will be Ly. Okay. So again, define parameters. Ly, I'm going to use 1 feet or nothing but 0.33. I'm adding. Close. And then again, there is methodology. So which method you are going to use? Just we have seen what is the method we are going to use, because just a minute. Yeah. Okay. So right, we STAD has given this load combinations, right? What is the combinations? What is the methodology for these combinations? Allowable stress design, ASD. So we are using ASD. Okay, select ASD and add, and then go for STP. STP is the command which is used to define the type of section, whether it is hot rolled steel or welded plate section. So we are using welded plate section here. If you see clear, index is here. 1 is for hot rolled section, 2 is for welded section. We are using welded plate sections, right? Nothing but hot rolled section will be poured in the mold. Okay. Welded section is nothing but plates will be connected to form web and flanges. So we are using welded plate section. So what is the number we have to give here? They have given. Okay. So that is the 2. I'm adding the command. Okay. And then track. Track is nothing but print the design output at minimum detail level. Print the design output at intermediate detail level. Print the design output at maximum detail level. So what is the difference between these three? Okay, if you click maximum detail level, shear force, bending moment, etc., everything, deflection at every point, we have used beam one command, right? So the beam, the entire beam will be divided into 12 parts, and it will be designed for each part. Okay, so for every 12th part, it will give the detailing. What is the shear force value there? What is the bending moment value there? What is the deflection value there? Like that, it will give. Okay, all these are unnecessary, because the simply supported beam will have maximum bending moment, maximum shear force, and maximum deflection at the center, right? Generally, I'm telling you in this example. So I know I don't need anything at the detail level. You can select any of those, no problem at all. It will not affect the design. Okay, so I'm taking 0, I'm adding it, and UNB. So UNB is nothing but unsupported length of bottom flange. Unsupported length of bottom flange. Just I'll go to the this diagram again. Okay, this sheet will be connected to the joists, right? So suppose I'm just the joist will be suppose. Okay, the joist will be in this direction. So okay, so this sheet will be connected to the top flange, and it will provide some sort of support to the web, but it will not connect to the bottom flange, right? If you observe here, this is the longitudinal direction of the joist. Okay, so the sheet will be connected like this. So it will be connected to the top flange. This is the top flange and this is the bottom flange. In between there will be a web. Okay, so it will provide some because the flange is connected to the web. Okay, so it will nearby. So Ly we have taken 0.33, and UNT is nothing but the screws will be directly connected to the top flange. It will also provide top flange unsupported length. Okay, so UNT also you can take it as 0.33, but these screws will not extend up to bottom flange. Okay, so these screws will not provide any support to the bottom flange. So what is the UNB, unsupported length of bottom flange will be? So it will be a full length. Okay, not 0.33, not 1, not anything. It will be a full length, because the screws will not extend up to the bottom joist. Bottom flange, right? So UNB will be unsupported length of bottom plane will be full length of the beam, that is 5 meters in our case. UNT will be screw spacing again. So in this 1 feet, nothing but 0.33. Suppose let us take, okay, 0.33 UNT. Again closed. So you have defined these comments or parameters, I can say. So you have to assign this to the beam. So I'm assigning each and every one. Stat editor method will be better than this one. Okay, how it will look like we'll see in the next class. Okay, that's why most of the engineers will use stat editor method only, programming like language. Okay, okay, I have assigned all these parameters, and then go to comments section. Commands. So you have assigned a code, you have assigned some type of parameters, etc. All this. Okay, so you have assigned the code, right? But you have to check with the code. Nothing but all the members are passing according to the given code and load combinations. So that will be done by check code command here. Check code will be added, and steel takeoff. Generally, what is the output generally we give to the clients in the steel structure? Weight, nothing but weight, right? Every output in the internal analysis we'll do whether section have passed, it is all internal matters. Okay, what is the final output we have to give to the client is what is the weight of the structure. So for that we have to give takeoff command. Okay, okay, takeoff command I have added, closed. Okay, so check code will be assigned to the structure, and steel takeoff will be assigned to the structure. So you have given everything, right? And then run design. Okay, you can do it by here run analysis, otherwise control F5 command. Okay, it will ask you structure has been modified, whether you have to save it or not. It is asking. I'm going to save this, just click enter, and then it will analyze and design. If you see here, 0 errors, 0 warnings, 0 notes. Okay, so it has cleared. So whether it is passing or failing, how to check? So if you click, this is the beauty of the Stat Pro while designing steel structures, I can say, because in RCC there will be no such criteria. It will take trial and error method like in the RCC structure, but here also it will take trial and error, but it will give you unity check ratio. Okay, unity check means what is the suppose I can say actual movement by designed movement. I can say unity check for the movement. I can say actual movement by design movement. Actual force by actual force means the coming force due to the loads given. Okay, actual force by the force generated or the force resisted by the structure. So those are called unity check ratios. If you click right click any in the user interface, it will open a menu. Okay, if you go to the structure diagrams here, if you go to the structure diagrams, and there are some design results here. Okay, design results, show diagram. If you click based on actual ratio, if you click OK, it is showing what is the ratio here, 0.164. Okay, generally the maximum passing limit will be it will be allowed up to 1. Okay, some contractors may restrict it to 0.95 only. So whenever it will be close to 1, the section will be economical. It will be close to 1. Okay, whenever it will be close to 1, the section could be economical. But in this case, the section is completely uneconomical because we have given heavier section. Okay, that much section is not needed here for the given loads. Okay, I can reduce the section. Okay, so everything clear? Okay, how to reduce the section? It is there in the properties itself. If you double click tapper here, you can reduce the depth of the web. Okay, suppose let us take 250 mm depth of the web. Okay, 250 mm depth of the web. So F1 is nothing but out to out of flange. If you observe, out to out of flange, nothing but you have to include flange thicknesses of top and bottom, right? So 250 mm. 250 mm top and bottom flange, 250 mm plus thickness of top of flange, thickness of bottom flange. Okay, 250 plus, suppose let us take top flange thickness as 5, bottom flange thickness as 5. So 250 plus 5 plus 5, 260. We have to give it in meters, 0.260. Suppose let us take thickness of web base 4 mm. Okay, again the other side also we are giving straight section. So 0.260. Both the depths will be same. We are giving straight section only here as of now. Okay, 150 is passing, so I can reduce it to 125. Okay, top flange thickness is suppose let us take I have given 5 mm. Okay, it is reduced to 125, and the bottom flange thickness can be reduced to 5 mm. Change. Yes, close, and again analyze the structure. So like that, you have to do in the user interface method. So if you observe, in the previous result, the ratio is 0.164 something, right? Now it has increased 0.4, but it is never close to 1. You have to reduce. You can, if there is scope, if there is much lesser section sizes in your inventory, you can reduce it to minimum sizes. Okay, no problem at all. Okay, so like this we have to give sections, and we have to design and analysis of a beam. Okay, everything clear?
Yes, sir.
Yeah, fine. If you are clear, we'll wind up this section as of today. Okay.
Sir, one question, sir. What about KY and KX for this beam?
Yeah, that is the definite question. If you observe, if you go to the design, I have given LZ as 5, LY as 0.13, UNT, UNB as something 1 values. Okay, these are nothing but all these are effective lengths in respective of local buckling axis, whether it will be of Y, whether it will be of top and bottom flanges. Okay, there is one more concept is there, LX. Okay, LX, if you double click this one, I'm going to property not to explain LX. Okay, this is the X direction. Okay, generally why we are not giving any LX command? Okay, because if you apply load in this direction, if any member is connecting to this direction, if you apply lateral load, suppose let us take, if you apply lateral load on this section like this, okay, I section is weaker. Okay, you know, I section will be stronger while taking gravity loads. I can say Y loads, local Y loads, it can take. It will be stronger, no problem at all. But if you apply in this direction, X direction, it will be weaker. So we are not giving any support. We are not giving any lateral loads here. That's why they have here. You can use LX here if you want. Okay, we can use LX. The same will be okay. So if there is any connecting member to the web, you can use LX. You can take LX as support. Okay, but KX, KZ, KY is effective length factors in respective of their respective buckling axis. Okay, those are factors only. Okay, generally for beams they will be 1. Okay, kx, ky, kz. Okay, so Lz is equal to kz into nominal length. Formula is Lz. Here we have given Lz, right? Lz is equal to kz into L. Okay, L is nominal length, kz is the effective length factor, Lz is nothing but design effective length. Clear? Yes. For columns, we have to define according to the support conditions. Okay, they'll change based on support conditions. Yep.
Yes, sir. Yes, sir. Got it, sir. For example, a strut pipe you are adding to the column, then in the X direction.
Yes, you can take it as Ly. No problem at all. We'll see all these things. Just as of now, we are designing a beam in this section. In this session, what are the concepts I have needed here? I have told you. Okay, I'll explain all these things wherever needed.
Sir,
Clear? Yeah.
what are the minimum thickness plate used for PB?
PEB generally we can use the minimum thickness of plate up to 4 mm. That is that too. It can be used for web only. Okay. For the flanges, generally they'll use minimum thickness of 5 mm.
Okay.
Okay. But in India they are going with 6 mm only. Okay. In India they are going with 6 mm only. I think so. Okay. Web will be a 5 mm.
Flange.
Only web. Webs are of 5 minimum. Okay. You know, flange thickness must be greater than or equal to web thickness. Flange thickness must be greater than or equal to web thickness. So that's why the minimum thickness in India may be, I think, 5, and the flange thickness minimum will be 6. Okay. But in other countries, they can use 4 mm minimum thickness for web and 5 mm minimum thickness for flange in order to get economical sections.
Okay, sir.
Clear? If you are clear, I'll wind up this
Sir,
session.
there is there is one confusion regarding the axis. When we see the results of bending moment diagrams and shear force, then
I'll tell you. Okay,
Yeah.
I'm going to the bending moment diagram. Yes, tell me now.
There
What
we,
is-
the axis along the member is x-axis.
Yeah.
Yeah, mx is
No,
and
no.
that is the moment
Actually, I'll tell you one thing.
Yeah.
I'll tell you one
while
thing.
looking at member,
No,
it is different.
No, just a minute. I'll tell you. These Z and Y axis they will show globally. These are not local axis.
No, but results are in local axis only, na?
No. These bending Z. Bending Z means,
Yes.
okay. So what
So
is the
Z
Z
axis
axis?
is
That is, tell me.
through the screen, means and perpendicular
Yeah,
to the
yes, exactly, perpendicular to the screen,
screen.
right?
Yeah.
Suppose how the moment will be. Suppose can I draw here? Yeah, I can. I think, yeah. Just a minute. Yeah. So suppose it is coming loads like this, right?
Yes.
Yeah. The bending moment will be like this.
Yes.
I can take.
This will be
Yeah.
mz.
Yeah, exactly. Just a minute. Give me.
Yeah.
Give me some time. So the resisting moment should be in this direction.
Yes.
Right? What is the axis of rotation? Where the axis should pass? Just tell me. Axis of rotation.
Z.
Yes, exactly. That is the bending moment about Z.
Yes.
Clear?
But while looking at the section, you today in your session you mentioned that I section. This is x and y you were mentioning.
Oh, that is local. I told you at that time only that those are local. It will give results according to the global axis. I told you, I think in the second class or third class, there are two types of axis. One is local
Yeah,
axis.
that I understand.
Ah,
But
ah.
in sections, no, these results when stat shows result, it shows in local axis only, na?
You mean to say this bending Z and shear Y, you are telling?
Yeah.
No, these are respect to the global axis. Because I'll tell you one thing. So, okay, what is the axis Z for this beam? Along the length, right?
Axis Z is perpendicular to this beam, yeah.
You are telling about global. And you have a doubt in local axis.
Okay.
Right? So, for example, Z axis for the beam. Along the length, right?
For this beam, for this beam, local will also be Z.
Just a minute, give me. Okay. Whatever I'm drawing here, 5 meters. That is the Z, right? Clear? Hello?
Yeah.
So what dimension you are seeing 5 meters, that is the local Z axis for the beam itself. Because cross section will
5
be
meters you are
sideways.
seeing is X. Oh,
You are confusing. You are confusing. I'll tell you. Cross section will be here only. If you double click this beam, just I'm going to the
local also.
Local is different from global. That is what I'm telling you.
Yeah. But for this particular beam, which is drawn along this.
Some disturbances I'm getting from you.
No, the length of the beam is in x-axis only, na?
No. For the local, you are telling?
Yeah. Am I audible?
Yeah, you are audible. Just tell me. Okay. I think if I render this section, you will understand. If I render this section, you'll understand. I'll try to render it. Okay. Now it is clear. You are seeing rendering.
Okay.
So this is the cross section. I'm rotating the member for you.
Yes.
This is the cross section. Actually, for the local Z axis, if I talk about local,
this is the Z axis.
This is the X
Local
direction. This is the X direction. Up is the Y direction. Length is the Z direction.
Oh,
but what about this one? Global is nothing but always horizontal. So local axis of Z will be global axis of X. Right? Understand?
Okay. Okay.
Okay, fine. Because if I render this section, you'll understand now.
Yeah, but it is showing Z only, na?
Where?
Is it
This
showing
length
global
is
or
Z.
local?
Results are in global only.
No, but this green axis it is showing. This is local or global?
No, this is global. Okay. What are the axes here?
Okay.
Okay. Fine.
Sir, if you switch on the local, I think axis you can understand, sir. There is option.
Yeah, there is one such command, I think. Shift O. Yeah. Shift O. Okay. You are seeing red line?
Yeah.
Okay. Just how can I rotate? Yes, there is one thing, right? How can I rotate?
Keep in isometric, sir.
No. Yes, I'm doing. I'm in this dimension. Okay. So this is all about local. Okay. If you are seeing 3 axis, right? So the green one is X axis. The red one is Y axis. The blue one is Z axis. These are all local axis. If you click Shift O, this will appear. Okay. These are all local axis. whatever UCS you are showing, universal coordinate system you are showing, those
Yeah,
are different from this.
but color wise, okay.
Okay, green color is X, red color is Y, blue color is Z. Those are local indication.
Okay, in global it was actually green was Z.
That thing, there are some certain commands to view the universal.
Okay, no
and,
problem, no problem. We'll further discuss.
Okay.
We'll
Yeah.
Yeah,
Yes. Okay, everything is clear. So
yeah. Thank you.
just have a wonderful night. I think IPL fever has been begun. So enjoy all. Okay, we'll meet in the tomorrow class.